Hi everybody, Justin here from chemistrynotes.com, and we're continuing today with naming compounds. So we've already covered naming ionic compounds, and that took us quite a while. Heavy topic. Last two videos were on naming ionic compounds. Now I want to talk a little bit about naming binary covalent compounds. Now, covalent compounds are also called molecular compounds, as we've discussed already. So, what are covalent compounds? Well, covalent compounds, or molecular compounds, are compounds formed between two nonmetals. So the member of nonmetals are the elements located in the upper right of the periodic table, to the right of the staircase, to the right of the metalloids staircase, and then also hydrogen's a nonmetal. So here's rules for naming covalent compounds. The first element is named first, using the full element name. Rule number 2. The second element is named as if it were an anion. Of course it's not, but it's named as if it were an anion. In other words, it gets the IDE suffix. Number 3. First time we've ever seen prefixes. Prefixes are used to denote numbers of atoms present. Remember, no prefixes were used before when naming ionic compounds, right? Prefixes are for covalent compounds or molecular compounds. The prefix mono, this is rule number 4, the prefix mono is never used for naming the first element. So as an example, CO, this is carbon monoxide. It is not monocarbon monoxide. And we'll learn about dropping one of those O's in just a second. So, prefixes. All right, what are they? We'll do 1 through 10. Mono, 1. Di, 2. Tri, 3. Tetra, 4. Penta, 5, like the pentagon. Hexa, 6. Hepta, 7. Octa, like an octagon, 8. Nona is 9. And deca is 10. All right, so those are the 10 prefixes you should know. All right, so moving on to page 2 of our notes here, just a few more notes on prefixes. When a prefix ends in O or A, like mono and hexa, for example, so when a prefix ends in O or A and the atom begins with O, like oxygen, we drop one of the O's or we drop the A. So monooxide becomes monoxide. Hexaoxide is not how we write it. Hexaoxide becomes hexoxide. All right, so we drop one of the vowels. All right, let's do an example for naming some covalent compounds. Name the following molecular compounds. A, N2O, B, NO, C, NO2, D, N2O3, E, N2O4. All these guys are located in the upper right of the periodic table, right? Dinitrogen monoxide, nitrogen monoxide. NO2, nitrogen dioxide. N2O3, dinitrogen trioxide. N2O4, dinitrogen tetroxide. A few more. F, PCl5. G, SF6. Next one, CO2. So PCl5, phosphorus, pentachloride. Sulfur, hexafluoride is going to be SF6. What's CO2? Most of us know that one anyway. Carbon dioxide. I. SO2 and SO3. SO2 is sulfur dioxide. SO3, sulfur trioxide. Now, in the last few videos, we discussed naming ionic compounds, so don't get SO3 right there confused with the sulfite ion, SO3 2-. SO3 above in J is its own full compound. It's a covalent compound, sulfur trioxide. All right, page 3 of our notes here. Well, the notes say, up until this point, we've been learning how to decipher the names of compounds, whether they be ionic compounds or the covalent compounds we just discussed. Up until this point, we've been learning how to decipher the names of compounds after we've been given the compound's formula, the molecular formula, the ionic formula. Well, what about the other way around? How could we figure out the compound formula from the name of the compound? So how do we go the other way this time? Well, that's what we're going to start talking about right now. So how could we figure out the compound formula after being given the name of the compound? All right. Well, our next topic then becomes getting formulas from the names of compounds. All right. Well, for ionic compounds, discussed in the previous two videos, for ionic compounds, we're going to use something called the crossover method. Sometimes it's called the crisscross method. When I lecture live, you see me go like this all the time because I'm crossing charges down. You'll see what I mean. Here's an example, calcium fluoride, Ca2 plus and an F minus. You cross the charges down and over, so you get a 1 and a 2 down below. The formula reduces to CaF2. For sodium hydroxide, we have Na plus 1. Lined up next to an OH minus 1, we cross the plus and minus 1s down. We clean things up, and then our final box becomes NaOH. All right? Now, we're not transferring down the negative sign of the charge for the anions. So lead 4 oxide, well, Pb4 plus, next to an O2 minus, we cross the plus 4 and the minus 2. We get Pb2O4, which we can reduce the Pb2O4 to plain old PbO2. Okay, so this is called the crossover method or the crisscross method. I do this all the time in lecture when I'm in front of my class. Number 2, how do we get formulas from covalent compound names? And of course, I'm going to say it over and over again, covalent compounds are the same thing as molecular compounds, right? Well, for covalent compounds, it's quite simple. You simply sound out the prefix system. So, as an example down there, it's hard for me to see here. It says tetraphosphorus decaoxide. Is that what it says? Tetraphosphorus decaoxide, that would be P4O10. All right, next example for covalent compounds. Nitrogen trifluoride, well, NF3. So this should be a very gratifying exercise here to know that this is fairly straightforward, getting the formulas for covalent compounds from the names. Diarsenic pentaiodide, well, that's As2I5. All right, so let's talk about naming acids now. So we've learned about naming ionic compounds, we've learned about naming covalent compounds, and now we have another category, acids. Now acids all start with H. We have a whole section devoted to this in section 14, which is chapter 14, if you will. So just a little bit right now exclusively on naming the acids. So acids are substances that produce H plus ions when they're dissolved in water. So for right now, just remember that acids for us they start with the letter H. There's no special tricks on learning their names. We just have to make flashcards, okay? There's 2 types of acids. Number 1, binary acids. Number 2, oxyacids. So the names there, binary acids and oxyacids, they give us hints on what the acids contain. Let's take a closer look at number 1, binary acids. Binary acids contain hydrogen, of course. In fact, it starts with the letter H, like all acids, plus 1 other element. Here are the examples. There's like 6 or 7 of them, I believe. They all start with hydro. Binary acids start with the phrase hydro. HF, hydrofluoric acid. HCl, hydrochloric acid. HI, hydroiodic acid. HBr, hydrobromic acid. All right, well, what about the last two? H2S, hydrosulfuric acid. And the last one, H2SE, rare, is hydroselenic acid. All right, so there's 6 binary acids. They all start with hydro something. Much larger class or category of acids are the oxyacids. As you might expect, they have to contain H, right? Acids start with H. For us right now anyway, acids start with H. They contain H, O, oxygen, right? Plus one other element. So here are the most common oxyacids that you should know, and I've kind of put them together in a way that's helpful to learn. H2SO4, sulfuric acid. H2SO3, one less oxygen. Sulfurous acid. So the trend you're going to see as we go down the page is ic and us. Us has one less oxygen than its ic counterpart. So if we have H3PO4 and H2PO4, I'm sorry, that's H3PO3. I'm sorry, H3PO4 and H3PO3, my bad. Phosphoric acid and phosphorus acid. So HNO3 and HNO2, these are nitric acid and nitrous acid. Now we have a grouping of more than just 2, but this is 4 of them. HClO4, perchloric acid. HClO3, chloric acid. HClO2, chlorous acid. HClO, hypochlorous acid. Sometimes hypochlorous acid is written HOCl, by the way. Now that little foursome there, the Cl can be replaced with Br or I or F, and you get things like perbromic acid, periodic acid, etc. The last few, H2CO3, it's in soda pop, carbonic acid, and HC2H3O2, acetic acid. It's in vinegar. Sometimes it's written CH3COOH, by the way. Now HCN, I'm putting on here, it's hydrocyanic acid. I realize there's no oxygen, it's not an oxy acid, but got to put it somewhere because I think it's common enough, at least in most chapter 2s for you guys, that you probably want to make a note of it and put it in your flashcards, okay? All right, moving on to our next page of notes here. I want us to do the following example problem. Name the following mixed assortment of compounds. So I think we'll actually do this in our next video, but I'm going to get this thing written out for you now. When I mean mixed assortment of compounds, I mean it could be an acid, it could be an ionic compound, it could be a covalent compound, and they're all going to be mixed in and jumbled together. And if it wants us to name these guys, we're going to be given what? We're going to be given the formula, okay? So A, HC2H3O2, starts with an H, doesn't it? B, NH4NO2, C, ICl, D, CO2S3, E, PB3PO42, F is KIO3, G starts with an H, H2SO4, H down there is SR3N2, I, P2O5, J, SNO2, K, Al2SO3, So when you see these problems written out all together like this, first thing you want to find out, is this an ionic compound or a covalent compound? And then remember how to name it according to your rules. First thing, is it ionic or is it covalent? If it's neither, it starts with an H, it's an acid, and you go from there. All right? See you next time, and we'll do this problem together.